last speaker is Dr. Richard Jones, and Rich will tell us about measurement of reserve and some important methodological questions that we need to address.
Thank you. So it's an honor to be here. I appreciate the invitation. I changed the title of my talk late. In reviewing my slides, I thought maybe a title, The Mismeasure of Reserve, might be better, throwing out an homage to my favorite author. So I'd like to cover in 15 minutes how reserve is approached in epidemiological and observational research, challenges to commonly applied approaches, including latent variable approaches, and other challenges in studying reserve. It's fun to go back and look at where this idea came from, and the idea of reserve in general is an old one, and it exists in many body systems, but probably the first group to put brain reserve or cognitive reserve together with brain changes and mental performance was Blessed, Tomlinson, and Roth, because they were, of course, one of the first to put quantitative measures of brain pathology and mental performance together in the same sample. And they identified a group of people with a high level of plaques at autopsy and had a new mental status measure. And they found a bunch of people who had a high level of brain pathology but relatively good performance, and used this notion of reserve to explain that disconnect. So I always like to remember that the whole idea for reserve comes from the imperfect relationship between how we can measure and observe brain pathology and how we can measure and observe cognitive performance. In epidemiology, as Yakov pointed out, we resort most commonly to proxy measures for cognitive reserve. This table I extracted from a pair of reviews that was done just prior to the first cognitive aging conference published in 2006 by Valenzuela and Satchev. And they did a systematic review and meta-analysis of studies on reserve in dementia and cognitive decline, and found that the most commonly used measures or proxies of reserve included educational attainment, occupation, usually trying somehow to identify cognitively demanding occupations, mental activities based on questionnaire, the type of behaviors that were done, and to the extent they're mentally stimulating, and premorbid IQ is used, but exclusively in studies of dementia. So a couple years ago, I wrote a paper where I discussed a lot of the details. Yakov was a big part of this, as were other people who are here today, where we talk about these measures in more detail. But let's just start out by saying that the problems or the challenges or what's wrong with reserve is that, although we heard some really interesting things today that I'd like to learn more about, right now for epidemiology, we don't have direct measures of reserve. We don't have well agreed upon indirect measures of reserve. And there's lots of things that are thought to be correlated or potentially cause higher levels of reserve. These are brain size, education, socioeconomic status, and mental activities. But the presumption that these things may cause reserve is not sufficient to define their effect. That is, the causes may be directly related to the cognitive outcomes. When we try to measure reserve in the context of a research study, we may be tempted to use latent variable models because we don't observe cognitive reserve directly. And it's useful and important to think about latent variable theory as we embark upon those types of activities. And I want to put in a plug for Denis Boursboom's books and papers on latent variable modeling. They've been very informative and formative to me and my thinking. But let me summarize those very long books with one slide. There's basically two approaches to thinking about the ontological status of latent variables, and they are anti-realist and realist positions. And the anti-realist position is one that views a latent variable and your latent variable modeling technique as a variance decomposition exercise. It's a mathematical abstraction, and it's a convenience tool used to try to get a handle on variables. A realist position would be, we actually believe that there's something that exists. It would exist even if we didn't even if we didn't measure it. And the measures that we're trying to get are measures of those real existing but unobservable constructs. And how you feel about a latent variable and how you think about reserve is important for how you build your models and how you interpret your results. So here's an example that you can find in the literature. This was a latent variable model that was used to operationalize the reserve concept. And these authors viewed a latent variable. So latent variable models are usually summarized with path diagrams, where latent variables are illustrated with circles or ovals, and observed variables with squares or rectangles. And this was an attempt to operationalize cognitive reserve as a latent variable that was measured by performance on a cognitive task, the PPVT, which is a picture vocabulary task, years of education, and the a word recognition task, the RAT. And when we look at latent variable models, there's a causal assumption that's built into these models, and that is that we have a latent variable that we presume causes the covariation among these symptoms or among these indicators, the observable variables, and that conditional on the underlying level of the latent variable, these observable indicators will be uncorrelated. But the key is this causal connection between the latent variable and the observables. And so here we're assuming that there's some unobserved characteristic of people that causes them to have high education and good performance on mental status tests. And if that's the definition of reserve we would like to use, that's great. Here's another example from the literature. Adam, sorry. This is a brain reserve model where this latent variable of brain reserve is thought to be some unobservable characteristic of people that we can't observe directly, but we assume exists and causes covariation in head size and physical height. So this is really a height latent variable, and it very well may be correlated with measures of observed cognitive performance, but it may not be exactly the latent variable we want to get at in the context of doing research on brain and cognitive reserve. There are two general frameworks for doing your latent variable modeling. One is called a formative measurement model, and one is a reflective measurement model. What I've been talking about today so far, and what you will most commonly find in the literature, are reflective measurement models. This is this idea that there exists some latent variable that causes covariation among observed variables. The formative measurement model is more like an index, and it's related to principal components analysis and related techniques. This is saying that there may be some latent variable, but it is caused by the observable indicators. And these observable indicators may or may not be correlated with each other, but together, they work together to form the latent variable, rather than having measures that reflect the latent variable. And I think that many of the proxies that we use to identify reserve fit more closely with a formative latent variable model than a reflective measurement variable model. So for a reflective measurement variable model, we really need to have things that we think could be caused by cognitive reserve, which would be the effect modification that Jakob has mentioned, things that represent the disjunction between pathology and performance. And that the variability in that construct may very well be related to education and socioeconomic status and other proxies, but there's a fundamentally different causal connection between the latent variable and the observables in those two instances. A problem with the formative measurement model approach is once we want to start predicting some outcome with that formative latent variable model, we run into this situation where we cannot distinguish formative measurement models from multiple regression models. So in which case, we're left with the conclusion that formative measurement models aren't really measurement at all. They're just a convenient abstraction, a variance decomposition, and so formative measurement doesn't really constitute measurement. And formative constructions, therefore, are generally going to be uninformative of the underlying latent construct. So if we want to adopt a realist position for this idea of cognitive reserve or brain reserve, we really need to identify reflective measurement models for that. I want to talk briefly about a new approach to measuring reserve based on residuals. This was a paper published by Bruce Reed and Dan Mungus and colleagues in Brain, and I've tried to blow up their figure in the next slide. They use an appropriate formative latent variable concept in identifying reserve, but they did not test this model against one of multiple regression, and I would like to have seen them do that, but I do think this is a highly innovative approach and potentially useful, and I think it could be extended in many interesting ways. This model also doesn't include modification of pathology and performance relationship, and that's an important part of the concept as Yakov has articulated it and what I'm buying into for reserve. Also, I've been talking all day about what I call problems on the X side of the problem, problems with reserve. But when we go to epidemiology and we want to study reserve, we have other problems. I've got this brain damage slide. In the background here, faintly, is Yakov's first slide on what is reserve. I don't know if you can see it. But also on the X variable side, we really need to have very sensitive measures of the brain damage part, because if we want to draw our causal connections, and the outcome side has its own set of problems in epidemiology. We want to make sure there's no confounding of our reserve marker with our outcome. We want to know if we're studying cognition or cognitive change. If we're studying cognitive change, we have to deal with floor and ceiling effects and practice effects, and selection bias is a really important problem. And the one that bothers me the most is the relationship between early life IQ and late life cognitive performance. This comes from the Scottish Mental Surveys of 1932. This is the Moray House Test IQ test score at age 11, and this is the Moray House Test IQ score at age 80. And the correlation is, about as good as you're going to get for two mental status measures in any sample, regardless of the fact that they're separated by about 70 years. And this is an important potential confound. IQ drives educational attainment and occupational choices and lifestyle choices. And what Yakov said earlier, which I'm going to start quoting now, is that reserve is what the brain does. And that's really nice. If I can get him to repeat that and write it down, that would be even better. But IQ is also one of the things that brain does. And when we're studying reserve, we may get confused and mix up IQ with reserve, and maybe that's what we want, and maybe that's true, and maybe it's not. So we need to be able to at least study and control that early life IQ measure. So, to summarize, I think the research challenges fundamentally are to understand whether neurocognitive reserve really exists. We would like to know what causes it. Those are formative indicators. We would like to know what is caused by it, and those are reflective indicators. Since